It is the summer of 1940, in an office in Detroit, Michigan. A telephone rings on the desk of Kaufman Thuma Keller, the president of the Chrysler Corporation, a man everyone calls KT. He picks it up. On the other end of the line is William Knudsen, the Danish-born industrialist who had run General Motors and who has now been pulled into Washington to lead the United States government's defense production effort. Knudsen does not waste time with pleasantries. He asks Keller a simple question. Can Chrysler build tanks? Keller, who runs one of the three largest automobile manufacturers in the United States, who oversees an engineering department that is the envy of the industry, who has spent his entire career building cars, gives an answer that has become one of the most famous lines in the history of American industrial mobilization. "I don't know," he says. "I've never seen one of these things." That is the honest truth. KT Keller, the head of a company that builds hundreds of thousands of motor vehicles a year, has never in his life seen a tank up close. Neither has almost anyone else in Detroit. The United States, in the summer of 1940, barely has any tanks at all. The Army ranks 19th in the world in size, just behind Portugal, and a substantial part of it still moves by horse. And now the government is asking the automobile industry to build tanks, an entirely unfamiliar product, by the thousand, faster than anyone has ever built tanks before. Keller says yes. Then he asks the obvious follow-up question. Where can I see one? Within weeks, Chrysler and the United States government have signed a contract, and Chrysler has broken ground on a vast new factory in the farm fields of Warren, Michigan, north of Detroit, that will become the Detroit Arsenal Tank Plant, the first purpose-built, mass-production tank factory in American history. But building the tanks turns out to be the easier half of the problem. The harder half is finding engines to put inside them. And the solution that Chrysler's engineers arrive at, under the pressure of a deadline that cannot be missed, is one of the strangest, most audacious, and most improbable pieces of engineering in the entire Second World War. They take 5 ordinary passenger car engines and they bolt them together into a single 30-cylinder monster. To understand why Chrysler did something so apparently insane as bolting 5 car engines together, you have to understand the engine bottleneck that strangled American tank production in 1941. The United States had decided, finally, to build tanks in large numbers. It had the factories, or was building them. It had the steel, the armor plate, the guns, the design for a good medium tank. What it did not have was engines. During 1941, the single biggest bottleneck in tank production was a shortage of engines, and in particular a shortage of the Wright Continental R975 air-cooled radial, the aircraft-derived engine that powered the standard M3 medium tank. The problem with the R975 was that it was an aircraft engine, and the aircraft industry needed it too. Every R975 that went into a tank was an R975 that did not go into an airplane, and in 1941, with the Army Air Corps expanding at a furious rate, the competition for those engines was fierce. There were simply not enough radial engines to go around. The tank program and the aircraft program were fighting over the same scarce power plant, and the tank program was losing. The Army needed an alternative engine, or several alternative engines, and they needed them immediately. There was no time to design a proper tank engine from scratch. To bring a brand new engine from a clean sheet of paper to mass production would take approximately 2 years, and the war would not wait 2 years. The only possible solution was to use engines that already existed, engines that were already in production, engines for which the tooling and the factories and the supply chains already existed. The War Department turned to the automobile industry and asked each manufacturer the same question. What do you have that might work?
This is the paradox at the center of the story. The United States in 1941 was the greatest manufacturer of internal combustion engines in the history of the world. It built more engines of more types in greater quantities than every other nation on Earth combined. Its automobile industry produced millions of engines a year, and yet, when the country needed engines for its tanks, it discovered that it had none that were suitable and available in the quantities required. The most prolific engine-building nation in the world had an engine shortage because none of the millions of engines it built every year had been designed for or was available for the specific and demanding application of powering a 30-ton tank. The resolution of this paradox is the story of improvisation under pressure. The American automobile industry could not conjure a purpose-built tank engine out of nothing in the time available. What it could do was take the engines it already had, the engines it was already building by the hundreds of thousands, and adapt them, combine them, and lash them together into configurations that would produce the power a tank needed. Each manufacturer solved the problem differently, and each solution revealed something about the engineering culture of the company that produced it. Ford cut cylinders off an aircraft V12 to make a tank V8. General Motors bolted two bus diesels together. And Chrysler, faced with the same problem, arrived at the most audacious solution of them all. Chrysler took 5 of its ordinary 6-cylinder passenger car engines, arranged them in a circle around a central crankshaft, and bolted them together into a single 30-cylinder engine that looked at first glance like something a mad scientist would have built. It was called the A57 Multibank, and it was, against all odds and all expectations, a success.
The popular history of the Sherman tank focuses on the tank, on its gun and its armor and its famous battles, on whether it was a match for the German Panther and Tiger. It has very little to say about what was inside the engine compartment, and almost nothing to say about the fact that the Sherman was powered by no fewer than 5 completely different engines over the course of its production, from 3 different manufacturers in 4 different basic configurations. The engine variety of the Sherman is one of the most remarkable and least appreciated facts about the most produced American tank of the war. And of all those engines, the strangest by far, the one that most deserves to be remembered and most completely has been forgotten, is the Chrysler A57 Multibank. The Multibank has been largely written out of the popular history because it is embarrassing, or seems embarrassing, in the way that improvised solutions often seem embarrassing in retrospect. 5 car engines bolted together sounds like a joke, like the kind of thing a desperate amateur would cobble together in a garage, not a serious piece of military engineering. The American Army itself did not want the Multibank, refused to use it in combat, and shipped most of the Multibank-powered tanks off to its allies. All of this contributes to the engine's obscurity, but the obscurity is undeserved, because the Multibank, for all its apparent absurdity, actually worked. It was reliable. It was durable. It powered thousands of tanks through years of hard combat in the hands of the British and other allies, and it performed, by the accounts of the men who used it, admirably. The story of the Multibank is the story of how desperate improvisation, executed with real engineering skill, produced something that looked ridiculous and functioned superbly. That is a story worth telling. The man at the center of the story was K.T. Keller. And to understand the Multibank, you have to understand Keller and the engineering culture he presided over. Kaufman Thuma Keller was born on November 27, 1885, in Mount Joy, Pennsylvania, the son of a family of Pennsylvania Dutch farmers. He did not come from wealth or privilege. He trained as a machinist, learning the trade with his hands, and worked his way up through the automobile industry through sheer mechanical competence. He had a deep, practical understanding of how machines were made, a machinist's feel for metal and tolerances and manufacturing. Walter Chrysler himself personally hired Keller and groomed him, and eventually appointed him president of the Chrysler Corporation in 1935. Keller ran the company for his mentor and friend, and after Walter Chrysler's death, he carried on the engineering-first culture that Walter Chrysler had built. That culture was the key to the Multibank. Walter Chrysler had set up an engineering department that was the envy of the entire automobile industry, housed by the time of the war in a 6-story office complex overseeing a huge testing laboratory equipped with all the latest devices, methods, and materials. Chrysler engineering was famous for its rigor, its thoroughness, and its willingness to tackle difficult problems through careful, systematic work. When the tank engine crisis arrived, this engineering culture was exactly what was needed. The problem was not one that could be solved by brilliance alone, by a single flash of inspiration. It was a problem that had to be solved by systematic engineering, by taking existing components and figuring out, through detailed analysis and exhaustive testing, how to combine them into something that would work.
Chrysler had the engineering depth to do this, and Keller, the machinist who had risen to run the company, had exactly the right instincts to back his engineers when they proposed something that sounded, on its face, completely crazy.
Before the Multibank, there was the factory and the first tanks. After Keller said yes to Knudsen in the summer of 1940, Chrysler moved with extraordinary speed. The company hired the famous industrial architect Albert Kahn, the same Albert Kahn who would later design the Willow Run bomber plant, to design a self-contained tank factory. Construction began in the winter of 1940 on 113 acres of former farmland in Warren, Michigan. The main building was gigantic, protected by 3-foot-thick concrete walls against potential bombardment. And the work happened at a pace that seems almost impossible in retrospect. Factory construction, the hiring of thousands of workers, and the engineering of the tanks themselves all happened simultaneously over the course of about 13 months. The urgency was such that the first tanks rolled off the assembly line before the factory walls were even finished. During the bitter Michigan winter of 1940 and 1941, with the building still open to the weather, Chrysler workers parked a steam locomotive inside the unfinished factory to provide heat so that the men could keep working. On April 24, 1941, the first M3 medium tank was driven out of the Detroit arsenal, one day ahead of its promised delivery date. K.T. Keller himself rode in the tank as it came out of the plant. At a ceremony shortly afterward, with the chiefs of ordnance and the Army, the mayor of Detroit, the governor of Michigan, and about 2,000 spectators present, the first production tank came roaring down in front of the crowd, snapped off telephone poles, plunged through a pond, blasted through some woods, and drove straight through an old, abandoned 2-story farmhouse. Chrysler had gone from never having seen a tank to mass-producing them in well under a year. But every one of those M3 tanks needed an engine, and the engine shortage was about to become the company's central problem. The discussion about the engine shortage came to a head in the autumn of 1941. The Army needed an alternative to the scarce Wright radial. Chrysler was asked, along with the other manufacturers, to propose a solution. The constraint was time. There was no time to design a new engine. To bring a brand new engine to production standard would take about 2 years, and that time did not exist. Whatever Chrysler proposed had to be based on tooling and components that already existed, that were already in production, so that it could be manufactured almost immediately without building new engine factories or new supply chains. K.T. Keller and his engineering team looked at what they had. What they had was the Chrysler flathead 6-cylinder engine, an L-head inline-6 of about 251 cubic inches, the engine that powered Chrysler, Dodge, and Plymouth passenger cars. It was a thoroughly proven, reliable, mass-produced automobile engine, built in enormous quantities with all its tooling and supply chains already in place. A single one of these engines produced only about 100 horsepower, nowhere near enough to move a 30-ton tank, which needed something on the order of 400 horsepower. But what if you used more than one? What if you took several of these proven car engines and combined them? Unhesitatingly, the account goes, Keller and his engineering team volunteered the Chrysler 6-cylinder engine for tank duty, and the engineers set to work on the problem of how to combine several of them into a single power unit. The number they settled on was 5. 5 6-cylinder engines, producing 30 cylinders in total, combined into one engine that would produce the power a tank needed. It sounded insane. It was, in a sense, insane. But the underlying logic was sound, and Chrysler engineering had the skill to make the insane idea actually work. The engineering challenge of combining 5 separate engines into one was formidable, and the way Chrysler solved it reveals the real skill behind the apparent madness. The basic concept was to arrange the 5 inline-6 engines in a circle, like the spokes of a wheel or the petals of a flower, around a central crankcase. Each of the 5 engine blocks retained its own 6 cylinders, its own pistons, its own connecting rods, and its own crankshaft. But the 5 separate crankshafts all connected through gears to a single central output shaft. The power of all 5 engines was combined at this central shaft and delivered as a single unified output to the tank's transmission. From the outside, with its 5 banks of cylinders arranged radially, the assembly vaguely resembled a 6-row radial aircraft engine, but it was not a radial at all. It was 5 complete inline engines clustered around a common output. The detailed engineering was where the real work lay. The 5 engines had to be precisely synchronized so that their power pulses combined smoothly rather than fighting each other. The gear train that connected the 5 crankshafts to the central output shaft had to be designed to handle the combined torque without failing. The engine's accessories had to be relocated and rationalized. The original passenger car engines each had their own distributor and carburetor, and these had to be repositioned to fit the new configuration. The 5 separate belt-driven water pumps of the individual engines were replaced with a single, more reliable pumping system. The cooling system had to be designed to keep all 30 cylinders at proper temperature within the confined space of a tank engine compartment. The whole assembly had to be made to fit, somehow, into the rear hull of a medium tank. Every one of these problems was solved through careful, systematic Chrysler engineering. The result was a single engine, designated the A57 Multibank, that combined 5 proven automobile engines into one tank power plant, using existing tooling and existing components ready for mass production in a fraction of the time a clean sheet engine would have required. The finished A57 Multibank was a genuine monster by any measure. It had 30 cylinders, arranged in 5 banks of 6. Each cylinder had a bore of 3 7/16 inches and a stroke of 4.5 inches, the dimensions of the original Chrysler passenger car engine. The total displacement was 1,253 cubic inches, which is about 20.5 liters, an enormous figure that dwarfed any single automobile engine of the era. In its tank configuration, the engine produced about 370 net horsepower at 2,400 revolutions per minute, with peak figures cited as high as 445 horsepower, and it generated approximately 1,060 pound-feet of torque, the twisting force that actually moved the tank. The compression ratio was a modest 6.2 to 1, appropriate for the fuel of the era. It was fed by Carter carburetors, was naturally aspirated, was liquid-cooled, and ran on gasoline. And it was heavy. The complete A57 engine package, including its radiator, cooling fan, and clutch, weighed 5,244 pounds. That is over 2.5 tons. The engine was relatively short because of its clustered radial-like arrangement, but it was dense and heavy, one of the heaviest tank engines of the war. Its size and weight required modifications to the tank that housed it. The engine compartment of the Sherman had to be lengthened by about 11 inches to accommodate the multibank, and a blister had to be added to the floor of the compartment to make room for the engine. The tanks that carried the multibank, the M3A4 and the M4A6, had visibly longer hulls than their siblings, lengthened specifically to fit the 30-cylinder monster. The engine was a beast, complicated, heavy, and strange. But the numbers that mattered, the horsepower and the torque, were right where they needed to be, and the engine could be built immediately from existing parts. The most remarkable thing about the A57 Multibank was the speed with which it went from idea to production. The initial engine discussion took place in the autumn of 1941. Less than a year later, the engine was in full mass production. On June 3, 1942, 9 months after the initial discussion, the first of 109 M3A4 tanks rolled out with the A57 engine installed. The M3A4 was quickly superseded by the M4A4 Sherman, the first of which was produced on June 30, 1942. From April of 1942 to September of 1943, Chrysler built 9,965 A57 multibank engines. Of these, 7,500 were installed in production tanks, and the remainder were built as spare engines to keep the fielded tanks running. This production speed was possible only because of the fundamental decision to use existing engines and existing tooling. Chrysler did not have to design and build a new engine factory, develop new castings, or create new supply chains for novel components. The A57 used the cylinder blocks, cylinder heads, pistons, connecting rods, and crankshafts of the existing Chrysler 251 cubic inch six-cylinder engine, components that Chrysler was already manufacturing in enormous quantities for its passenger cars. The genius of the Multibank, the thing that justified its apparent absurdity, was precisely that it could be built immediately, in quantity, from parts that already existed. A clean-sheet tank engine would have been more elegant, lighter, and simpler, but it would not have been available until 1943 or 1944. The Multibank was available in 1942, when the tanks were needed. In a war where timing was everything, the engine that could be built now beat the engine that would be perfect later. Here, the story takes its characteristic turn, the turn that runs through so many of these wartime engineering stories. The United States Army did not want the A57 Multibank. The engine was, from the Army's point of view, too complicated. 5 separate engines meant 5 times the number of things that could go wrong. 5 sets of spark plugs, 5 carburetors, 5 ignition systems, 5 cooling circuits, all of which had to be maintained, all of which represented potential points of failure. The maintenance burden was real. A mechanic working on an A57 had to understand and service what amounted to 5 automobile engines simultaneously within the cramped confines of a tank engine compartment. For an army that valued simplicity and standardization in its field equipment, the Multibank was a maintenance nightmare waiting to happen. The Army's preference was for the Ford GAA, a purpose-built V8 tank engine that was simpler, lighter, and more conventional. The Army standardized on the GAA-powered M4A3 as its preferred Sherman variant for its own use. The A57-powered M4A4 was restricted from overseas use by American forces. It was not used in combat by United States forces, and in May of 1945, it was classified as limited standard, the designation for equipment that was acceptable but not preferred. The Army had decided that the Multibank, for all its ingenuity, was too complicated for its purposes. This decision would have been a death sentence for the engine if the United States had been fighting alone. But the United States was not fighting alone. It was supplying half the world, and the tanks the American Army did not want found eager users among its allies. The nation that wanted the M4A4 and its Multibank engine was Britain. The British military, desperate for tanks of any kind throughout the war, received over 7,000 M4A4 Shermans under Lend-Lease, designating them the Sherman 5. And the British, somewhat to everyone's surprise, found the Multibank to be an excellent engine. In British service, the A57 proved to be durable, reliable, and efficient, a thoroughly satisfactory power plant for a medium tank. The British deployed their Multibank Shermans across every theater where they fought, in North Africa, in Italy, in Normandy, and across northwestern Europe into Germany. The reasons for the British satisfaction were several. The British military maintenance system was different from the American system, and the British were willing to invest the effort required to maintain the more complex engine properly. Once the maintenance procedures were established and the mechanics were trained, the Multibank ran reliably. And the engine had genuine virtues that compensated for its complexity. It was smooth running because the 30 cylinders fired in a sequence that produced a very even flow of power. It was powerful and torquey, and it had a remarkable survival characteristic that emerged from its very nature as 5 separate engines. The Multibank could reportedly keep running even with 2 of its 5 engine banks disabled by combat damage. A tank that took a hit that knocked out 40% of its engine could still limp home on the remaining 60%. This redundancy, an accidental byproduct of the 5-engine design, was a real advantage in combat, where a single-engine tank that took a hit to its power plant was simply immobilized. The Multibank, for all its complexity, gave its crew a margin of survival that simpler engines did not. The M4A4 Sherman, with its A57 Multibank engine, fought across the major theaters of the war in British and Commonwealth hands.
In North Africa, the Sherman first proved itself against the German Afrika Korps, and multibank-powered tanks were among those that turned the tide in the desert. In Italy, the multibank Shermans fought through the long, grinding campaign up the peninsula, through mountains and river valleys against determined German defense. In Normandy and across northwestern Europe, British and Commonwealth armored units drove their multibank Shermans from the invasion beaches across France, Belgium, and the Netherlands and into Germany itself. The engine that the American Army had rejected as too complicated carried British tank crews through some of the hardest fighting of the war, and it carried them reliably. A small number of multibank tanks went to other Lend-Lease partners. 2 went to the Soviet Union for evaluation, though the Soviets, who preferred the diesel-powered M4A2, did not adopt the multibank in quantity. About 274 went to other Allied nations. The great majority, though, went to the British, who became the primary users of the multibank Sherman and who valued it. The engine that had been born out of desperation in a Detroit engineering office, that had looked like a joke, that the American Army had refused to take into combat, found its war in British hands, fighting from the deserts of North Africa to the heart of Germany. It did its job. It did not catch fire any more than other gasoline tanks. It started in the morning and ran all day, and when it took a hit, it often kept running on 3 or 4 of its 5 engines. The crews who depended on it came to trust it.
The ultimate vindication of the A-57 Multibank is that it worked reliably in hard combat service for years. This is not what one would expect from 5 car engines bolted together in a circle. The intuition that such a contraption would be fragile, unreliable, and prone to constant breakdown was natural and widespread, and it was wrong. The Multibank was, by the accounts of those who used it, one of the more reliable Sherman engines. Its apparent crudeness concealed real engineering sophistication. The synchronization of the 5 engines, the design of the central gear train, the rationalization of the cooling and accessory systems, all of these were solved with genuine skill, and the result was an engine that functioned as a coherent whole rather than as 5 engines fighting each other. The engineering lesson of the Multibank is a lesson about the difference between elegance and effectiveness. The Multibank was not elegant. It was the opposite of elegant, a sprawling, heavy, complicated assembly of 5 separate engines. A purpose-built engine like the Ford GAA was far more elegant, but the Multibank was effective and it was available, and in the conditions of 1942, availability and effectiveness mattered more than elegance. The Chrysler engineers had been handed an apparently impossible problem to produce a tank engine immediately from existing components, and they had solved it with a design that violated every aesthetic principle of engine design and yet worked. There is a kind of engineering courage in that, a willingness to do the ugly, practical, effective thing rather than wait for the beautiful, elegant, unavailable thing. The Multibank was ugly and practical and effective, and it helped win the war. That is a vindication worth more than any award for elegance. The A-57 Multibank was one part of a larger achievement, the transformation of the American automobile industry into the arsenal of democracy. The Detroit Arsenal tank plant that Chrysler built in Warren, Michigan, became the single most productive tank factory in the United States. By the end of the war, the Arsenal had built 22,234 tanks, over 1/4 of all the tanks produced in the United States. Chrysler, which in 1940 had never seen a tank, became the largest single tank manufacturer in American history, applying the mass production principles of the automobile industry to the manufacture of armored vehicles, something that had never been done before at that scale. This was the real significance of the Multibank and of everything around it. The American automobile industry possessed an enormous, flexible, sophisticated manufacturing capability, and when the war came, that capability was turned to the production of weapons with a speed and at a scale that no other nation could match. The Germans, who had a long military tradition and purpose-built weapons designed by specialist firms, could not match the sheer output of the American automobile industry turned to war. Germany built about 6,000 Panther tanks during the entire war. America built nearly 50,000 Shermans. The Multibank engine, the 5-car engines bolted together, was a perfect emblem of how this was done. It was not the best engine that could be designed. It was the engine that could be built right now in quantity from what was already on hand by an industry that knew how to mass produce. That capability, the capability to improvise and produce at scale, was the decisive American advantage, and the Multibank was one small, strange, brilliant expression of it.
K.T. Keller continued to lead Chrysler through the war and beyond. Under his leadership, Chrysler did not only build tanks. The company manufactured a vast range of war material, becoming one of the most important defense contractors in the country. Keller's machinist's instincts, his deep practical understanding of manufacturing, served the war effort well. He understood how to take a design and turn it into mass production, how to organize factories and workers and supply chains to produce weapons in enormous quantities. The Detroit Arsenal was his creation, proposed and built under his direction, and it was one of the great manufacturing achievements of the war. After the war, Keller continued as president of Chrysler until 1950, when he became chairman of the board, again following in the footsteps of his mentor Walter Chrysler. He remained chairman until 1956. In recognition of his contributions to the war effort, he received the Medal for Merit, the highest civilian award of the United States during the war, and the Air Force Exceptional Service Award. After leaving Chrysler's day-to-day management, Keller was asked by the government to oversee the United States guided missile program in its early years, applying his manufacturing expertise to the new field of rocketry. He died on January 21, 1966, in London at the age of 80. He is remembered, when he is remembered at all, as the machinist who rose to run Chrysler, who said he had never seen a tank and then built more of them than anyone else in America, and who backed his engineers when they proposed bolting 5-car engines together into a 30-cylinder monster. The Multibank was his kind of solution, practical, audacious, and effective, and it bore the stamp of his engineering-first leadership.
A number of A57 Multibank engines survive today, preserved in museums and in the hands of private collectors and tank restorers. Some of them are still in working order, installed in restored M4A4 Sherman tanks that occasionally run at military vehicle shows and historical demonstrations. To see and hear a Multibank running is a remarkable experience. The 30 cylinders firing in their carefully orchestrated sequence produce a sound unlike any other tank engine, a smooth, deep, complex mechanical roar that reflects the engine's unusual configuration. The Walter P. Chrysler Museum displayed a Multibank engine, showing the public the strange, dense, radially arranged assembly that powered thousands of Allied tanks. The survival of these engines, and the fascination they hold for those who encounter them, is a small measure of justice for an engine that was largely written out of the popular history. The Multibank was strange, and strangeness attracts attention, and so the engine that the official histories overlooked has found a kind of afterlife among enthusiasts who appreciate exactly the audacity that made the official histories uncomfortable. 5-car engines bolted together is a story that people remember once they hear it, precisely because it sounds so improbable. The engine that nobody chose first, that the American Army rejected, that fought its war in foreign hands, has become, in the world of tank enthusiasts and engine aficionados, a celebrated oddity, an emblem of wartime ingenuity at its most gloriously unconventional.
The lesson of the A57 Multibank is a lesson about constraints and creativity. The Chrysler engineers did not build the Multibank because it was the best possible tank engine. They built it because it was the best engine they could build under the specific, brutal constraints they faced, the constraint of time above all. They could not design a new engine because there was no time. They could not get enough of the existing radial engines because the aircraft industry needed them. So they did the only thing they could do. They took what they had, the proven car engine they were already building by the hundreds of thousands, and they combined it, 5 at a time, into something that would do the job. The constraint forced the creativity. The impossibility of the conventional solution drove them to the unconventional one.
This is a pattern that runs through the entire history of wartime engineering and through the entire story of the American industrial war effort. The Americans were not always, or even usually, the most elegant engineers. The Germans often built more elegant, more sophisticated, more technically advanced weapons. But the Americans were the most effective improvisers, the most willing to do the practical, ugly, available thing, rather than wait for the elegant, perfect, unavailable thing. The Multibank embodied this. It was a 30-cylinder monster cobbled together from 5 car engines, and it was exactly the right answer to the question the war was asking in 1941, which was not, what is the best engine, but what engine can we build right now? The willingness to ask that second question and to accept the strange answer it produced was a large part of why the American industrial war effort succeeded. The Multibank was ugly, and it worked. And in a war, working beats beautiful every time. In a war decided by what could be built was 5 car engines bolted together. It was 30 cylinders. It weighed over 2.5 tons. It looked like something a mad scientist would have assembled in a fever dream. 5 complete automobile engines clustered in a circle around a central shaft, each with its own crankshaft and its own pistons and its own spark plugs, all of them combining their power into a single roaring output. It violated every principle of elegant engine design, and it worked. It powered thousands of tanks through years of hard combat, reliably, durably, even keeping the tank moving when 2 of its 5 engines were shot to pieces. The engine that should not have worked, worked. K.T. Keller, the Pennsylvania farm boy who trained as a machinist and rose to run Chrysler, who told the government he had never seen a tank and then built more tanks than anyone else in America, backed his engineers when they proposed the impossible. And his engineers, working under the engineering-first culture that Walter Chrysler had built, took an apparently insane idea and made it real through systematic, skilled, patient work. They synchronized the 5 engines, they designed the gear train, they solved the cooling, the accessories, the installation. They turned a joke into a weapon. And they did it in less than a year, because the war could not wait, and because they understood that the engine that could be built now was worth more than the engine that would be perfect later. In a war fought between industries, the industry that could take 5 ordinary car engines and turn them into a tank engine in under a year was the industry that won. The Germans had purpose-built tank engines, beautifully designed, technically superior. The Americans had a 30-cylinder monster cobbled together from passenger car parts. The Germans built 6,000 Panthers. The Americans built 50,000 Shermans, powered by whatever engines could be improvised, including 5 car engines lashed together in a circle. The Multibank was not in any hall of fame. It was the engine that nobody chose first, that the Army rejected, that fought its war in the hands of allies. But it ran. It started every morning, it pulled the tank all day, it kept going when it was shot, and it did not catch fire when somebody hit it. In a war decided by what worked, the 30-cylinder monster worked. That was enough. It was, in the end, one of the strange and brilliant improvisations that won the war.